Welcome to this presentation on the process of reverse engineering, presented by DeepLearn. Moving forward, let's delve into the specific processes involved in reverse engineering. At its essence, reverse engineering involves analyzing software to gain insights into its design and specifications. This analysis is critical as systems often become convoluted over time. To facilitate this, various tools and techniques are employed, including program understanding tools like browsers and cross reference generators, which help developers navigate through complex code bases. It's important to note that reverse engineering is distinct from re engineering. While reverse engineering focuses on understanding existing systems, re engineering involves modifying or rebuilding systems based on that understanding. Imagine a scenario where a company is tasked with updating a legacy system without any documentation. How could reverse engineering allow them to bridge that gap? By reconstructing the architecture of the original system, teams can ensure that essential functionalities are preserved while introducing modern improvements. Let's clarify the distinction between forward engineering and reverse engineering. Forward engineering is the process of building a system from scratch, beginning with requirements and moving through design to implementation. In contrast, reverse engineering involves taking an existing system and working backward to extract its architecture and functionality. In the context of the software development lifecycle (SDLC), understanding this difference is vital. For instance, while forward engineering might focus on creating a new feature based on user requirements, reverse engineering can help teams understand why an existing feature behaves in a particular way or how it can be improved. Think about a time when you encountered a software application that didn't meet your expectations. Was it due to poor design or perhaps a lack of understanding of user needs? This is a common challenge in software development, and understanding both forward and reverse engineering can provide insights into how to create systems that align better with user expectations. Why is reverse engineering necessary in today's software landscape? One of the primary needs arises from the loss of documentation, which can occur for various reasons. Original developers move on, documentation becomes outdated, or systems evolve beyond their initial designs. Reverse engineering serves as a vital tool for recovery. It assists in maintaining systems by identifying side effects and anomalies that may not be immediately apparent. Moreover, as companies look to migrate systems to new hardware or software platforms, reverse engineering plays a crucial role in ensuring compatibility and functionality. Consider a company that has relied on an outdated software platform for years. As they plan to transition to a more modern solution, reverse engineering their current systems allows them to identify which components can be reused, saving both time and resources. How might the insights gained from reverse engineering reshape the future development of software systems? Let's outline the phases involved in reverse engineering. The first phase, raw view extraction, involves gathering basic information about the system from various artifacts like source code and execution traces. This raw data forms the foundation for further analysis. Next, we move to database construction, where this raw information is organized into a coherent format, making it easier to analyze and manipulate. Following that, view fusion occurs, where different perspectives of the data are combined to form a more comprehensive understanding of the architecture. Finally, architectural analysis allows us to test our hypotheses about the system's structure and behavior. Each of these phases is interconnected, and it's important to recognize that reverse engineering is not a linear process. Rather, it is iterative, often requiring revisiting earlier steps based on new findings. Imagine you are tasked with reconstructing a complex system. How would you approach this task, and what challenges might you encounter during each phase? Reflect on the dynamic nature of software development and the role of reverse engineering in navigating those complexities. As we explore the tools available for reverse engineering, we find a variety of options at our disposal. Tools range from static analyzers that examine code without executing it to dynamic analysis tools that observe system behavior during execution. The combination of these approaches is critical. Static analysis can reveal the structure of the code, while dynamic analysis can capture runtime interactions that are often missed otherwise. This duality allows for a more holistic view of the system, enhancing our understanding. Automated tools play a significant role in streamlining the reconstruction process. They help in extracting information efficiently, but it's crucial to remember that these tools are not a substitute for human expertise. The interpretive nature of reverse engineering requires a skilled eye to discern meaningful insights from the data. Think about the last time you used a tool to analyze data. How did it enhance your understanding, and what limitations did you encounter? This reflection can foster a deeper appreciation for the interplay between human insight and technological support in reverse engineering. While reverse engineering offers numerous benefits, it is not without its challenges. One significant limitation is that many tools have difficulty extracting certain architectural elements, such as layers or connectors, from the source code. These elements do not have explicit representations in programming languages, making them elusive. Furthermore, the interpretive nature of architectural reconstruction means that human expertise is essential. A skilled architect or engineer must analyze the data and draw conclusions about the underlying architecture, which requires a deep understanding of both the system and the broader context in which it operates. Consider a scenario where a reconstruction tool outputs conflicting information about a system's architecture. How would you approach resolving this discrepancy? This question highlights the importance of critical thinking and domain knowledge in navigating the complexities of reverse engineering. Looking ahead, the field of reverse engineering is poised for significant advancements, particularly with the integration of artificial intelligence and machine learning. These technologies will enable more sophisticated analysis of systems, potentially automating aspects of the reconstruction process and providing deeper insights into architectural patterns. As we embrace these advancements, it's essential to consider the implications for software architecture and design practices. How will the evolving landscape of reverse engineering influence the way we approach system design and maintenance in the future? Reflect on how emerging technologies might reshape your understanding of software systems. Will they enhance your ability to create robust architectures, or will they introduce new challenges that require us to rethink our methodologies? In conclusion, we've explored the multifaceted world of reverse engineering and its significance in software architecture and design. We've defined key concepts, examined processes and phases, and discussed the tools available for effective analysis. Understanding reverse engineering is paramount for anyone involved in software development, as it equips you with the skills to navigate complex systems and ensure their longevity and maintainability. As a call to action, I encourage you to integrate reverse engineering practices into your workflows. Whether you're working on legacy systems or developing new applications, applying these principles can lead to more informed decision-making and better architectural outcomes. Before we wrap up, consider this. How can you leverage the concepts we've discussed today to enhance your own software projects? The answers to this question may open up new avenues for growth and improvement in your practice. Thank you for engaging in this critical discussion. Thank you for watching this presentation.